Our next video is about equations of lines. I'm going to start by giving you 5 different ways you might see equations written. The first one I know that you've seen many times. It's called slope-intercept form, and it's y equals mx plus b, where m represents the slope and b represents the y-intercept. Hence the name slope-intercept form. The next one is called point-slope form, and I think you most likely have seen this one. It's not as common as slope-intercept, but it's still very important. So point-slope form is written as y minus y1 equals m times x minus x1. In this case, your m is your slope, and x1, y1 is the point that you go through, that the line goes through. By the way, just a comment, all of these are in your book on page 8. I kind of just took them off the table on there, so you can also check that out. You can read through the book. There's a lot of good stuff in there. If you look hard enough, you'll find it. But you can also watch the video. The next thing is the general form of a line. So you might have seen this in a very similar form called standard form. So the general form is ax plus by plus c equals 0. Now if you remember standard form, it was similar except that it was equal to c. If you don't remember standard form, that is completely okay. But just know the general form is written like this. And one thing I want to comment on is the a, the b, and the c really have no meaning when we're working with lines. They don't represent anything. They are just constants. So oftentimes you just try to manipulate the numbers around so that you get it into this form, you get it equal to 0, but it doesn't really mean anything until you actually solve for y and get it in slope-intercept form. And I'll give you some examples from there. The next type of thing you're going to see is a vertical line is always going to be written as x equals, I'm going to call it x equals a, but in this case a is a constant. Again, it's just going to be x equals a number. It could be x equals 3, which would be a vertical line that passes through x equals 3 on the x-axis. It could be x equals negative 27.5. It can be x equals 10,853. There's a lot of different possibilities for what that a is going to be. Similar to a horizontal line, it's always going to be y equals something. I'm just going to call it b. Once again, b is a constant. It can be any number. So we're going to do an example that involves both point-slope form and slope-intercept form. We're going to write the equation of the line that passes through negative 1, 3, and has slope 5. So in point-slope form, this is actually very easy. So you have the formula, but I'm going to rewrite it just for the sake of this problem. And in this case, we have x1 is negative 1, y1 is 3, our slope is our m, which is 5. We are just going to write this as y minus 3 equals 5 times x. Since we have minus x1, and x1 is negative, it's going to become plus 1, and that is my answer in point-slope form. That one's nice and easy. Slope-intercept form, there are actually 2 ways to do it. I'll show you both methods, and you can choose which is best for you. I honestly don't care which one you use. You'll find they both take the same amount of time. Some people like the method 1, some people like method 2. Just make sure that you, on a test or quiz, show your work, and it doesn't really matter to me which way you do it though, as long as you show your steps. So method 1 is you start by writing it in point-slope form. Then, to get it into slope-intercept form, which you might remember is y equals mx plus b, you must solve for your y. We do that by distributing this 5 to the stuff in the parentheses, Then we move the 3 over, and we get y equals 5x plus 8. So method 1, it's pretty quick. Method 2 is also pretty quick. Just use whatever one you like better. So for our second method, we are going to avoid using point-slope form altogether and just start right away with slope-intercept form. We don't know our intercept, but we know our slope. And we also know a point that's on our line. So I'm going to start by substituting in that slope that I know, which is 5, put that in for m. Then I can find my b, my y-intercept, by substituting in the point. In the end, I get 3 equals negative 5 plus b. Just move over the 5. I end up getting b equals 8. Do not just stop there, or otherwise you'll get the problem wrong, because we're looking for the equation, which is y equals 5x. Now I substitute the b in, plus 8. Either way works. You can use both if you want to. Make sure that you did it right. That also is a good way to do it, but it's your decision. So I'm going to use the same directions. We're going to find the equation of the line. Whenever I don't ask you to give me a form, I always want you to do it in slope-intercept form. So you're always going to do it in y equals mx plus b form. So I want you to find the equation of the line that passes through these 2 points. Now, a little trick I'm going to give you is that whenever you see 2 points, you almost always are going to have to use the formula for slope. That's really the only formula that we have that uses both of those 2 points, so that's generally what you're going to do for those. So I'm going to call this one x1, y1, this one x2, y2. Doesn't really matter which one you put as 1 and 2. And I'm going to go ahead and do 9 minus negative 3 over negative 1 minus 5. That's going to give me 12 over negative 6, and that gives me a slope of negative 2. I'm not done, but I have a good start. Now, I like method 1 that I did on the previous slide, so I'm going to use that. I'm going to find my point slope first. Here's the formula again, just so you have it. You don't have to write it if you don't want to. And even though I've listed 5, negative 3 as x1 and y1, I can still use the negative 1, 9. It doesn't really matter. It's up to you. So what I'm going to do is I'm going to put in my negative 1, 9. I get y minus 9 equals my slope, my m that I just found, negative 2 times x minus negative 1. Which actually, if you want, you don't even need to do this step. You can just write it as x plus 1. From there, I am going to distribute. That gives me y minus 9 equals negative 2x minus 2. I move over my 9, and I get y equals negative 2x plus 7.